Hello, I'm here to discuss uh, a very primary and interesting area of navigation further, and we call them as the trigonometric ratios. The trigonometric ratios. Now, we will be discussing that after I show you this picture. This picture shows three bridges, and if you may note, the three bridges have something very common, and the very common thing is the triangles. This is a Warren Truss bridge, an interesting kind of a bridge, one of the most basic kind of bridges that were ever made. Of course, there have been several further magnificent bridges made on the basis of this, of course. But the Warren Truss bridge uses triangles, as you may see, and and is one of the most strongest kind of structures of amongst bridges. If you see, they got right angle triangles. If I may just draw this one over here, it uses right angle triangles. Yeah, there we are. I hope you can see that. Yeah, there we are. The background possibly. All across, the right angle triangles. And 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 the strength of this bridge is based on these triangles. But when you're doing an engineering, it is necessary that apart from your design, the material losses needs to be the least. And that's when trigonometry or mathematics comes into being to predict what can be the material cost, to predict what is the length needed over there, and says that the company who's doing this has to bear the minimum amount of losses. So uh, so here we have the use of trigonometry, and we use a trigonometry, as I've discussed. They use right angle triangles and to understand or predict corresponding lengths. I have this triangle over here, and and let's presume that this is uh, this is an angle theta. So I've discussed with you that the opposite side to this would be the one over here. The one on the base. In my previous videos, I mentioned that this would be the base for this particular angle. And of course, the most common one, which is always there in a right angle triangle, is the hypotenuse. A person may compare these three sides 2 by 2 in in about 6 ways. A person who sees the hypotenuse first may compare the opposite side in terms of the ratio, and we can call that as opposite to the hypotenuse. The next one is you may compare the base to the hypotenuse. That may be also possible. There may be another comparison that is possible, that is the opposite side of this particular angle may be compared to the base. Of course, there are three more in which we can make the reciprocals of these three primary comparisons. Now, now in order to make it more easier for a learner, these primary three ratios were given certain names. The first one, when you compare the opposite to the hypotenuse, this is called as the sine of the angle to which this opposite side and hypotenuse bear. The short for this was called as SIN. S-I-N, sine of the angle, whatever the vertex may be. Let's presume that I place this vertex as, say, A. So I could call it as A. This is one of the ways of writing. Or you could also write it by the notation as sine of theta. So sine of the angle could be written as sine of the vertex or sine of theta. But essentially what you must understand that all that we're going to try and do over here is compare two opposite sides. So is the second one, which is called as the base to the hypotenuse. Now this has a special name and it's called as the cosine. Cosine. Like you see, the word comes in from here itself, from the sine. Cosine is cooperating with the sine. That kind of a word. And you'll realize in time as to why it's been called as a cosine. You'll realize that. Cosine of the angle, and therefore cos of A or cos of theta. Likewise, the last one is very interesting. It compares the opposite side, this is the opposite side, to the base. This has a special name and we call this as a tan or the tangent of the angle. That's tan of A or tan of theta. Of course, you can use other notations also. Apart from theta, you can use any other notation, but you must establish that in your work. Let us try a few basic questions based on this. And so let me just place another triangle for you. And this time let me call this the angle over here as, say, some alpha. It's a 90-degree triangle, and let me take this as a 10 centimeter, this to be as, say, some 5 centimeters, and I wish to find, in the first place I wish to find x, and then we can go on to find all the ratios over here, the three ratios, sine, cos and tan. Now you may recollect the Pythagoras theorem. The Pythagoras theorem would be associating the hypotenuse with the opposite and the base. So here, so we have x square, which would be equal to a 10 square plus a 5 square. You can go ahead and grab your calculators and do the calculation for finding the value of x. So I'll do the calculation without a calculator this moment in the form of root. So this is going to be 100 plus a 25. So my x square equals 125. So my x would be equal to the square root of 125. If it is possible for you to place this in a more simplified version, you must always. So I could always break it down into a 25 into a 5. That's a perfect square and a non-perfect square. And break it down as square root of 25 into square root of 5. That turns out to be as a 5 root 5. So that is my hypotenuse over here. It is a 5 root 5. Let us go ahead now and try to find the values of these angles. Not the values, I'm so sorry, the trigonometric ratios. Beginning with sine. Sine of alpha compares the opposite to the hypotenuse. The opposite is a 10 over here. We notice this is my opposite side to the angle upon the hypotenuse, which is 5 root 5. You can always simplify on this. So 5 ones and 5 twos, that's 2 over a root 5. Don't get perturbed with this. It's just a comparison. Let's take sine of, oh, I'm so sorry. This would be Let's go on to the cosine now. Okay, the cosine. The cosine of the angle alpha. The cosine compares the base to the hypotenuse, and therefore it would be 5 over a 5 root 5. Simplifying on that, 5 ones and 5 ones, and that's a 1 over a root 5. That's a cosine. Now, the next one that we have is the tangent. The tangent of the angle. And there we are, of the angle alpha. The tangent compares the opposite to the base. So that's going to be 10 over 5. That's 2:1. Now, this should help you understand in a very rough manner as to what the sine, the cos and the tan do, the three ratios. Okay. In my next video, I will discuss some more implications of these three ratios in higher problems.